Hi, this is our Algebra B project and we are Andrés Ureña, Íñigo Benito, and José María Arizaga. This is the index for our project, which consists of objective, background, and mathematical calculations, as well as a conclusion and bibliography. Our objective is to study if electoral outcomes can be predicted through the use of matrices and demonstrate so with US elections examples. The background is that election forecasting refers to the estimation of the number of voters each candidate is going to get in a determined election.
Markov chains is a mathematical system created by the Russian mathematicians Andrei Markov. It is a process in which the probability that one event occurs depends only on the immediate preceding event. It is a memory-less process. Matrices is one of the many mathematical methods to predict an election result. When we use this methodology, we name our first matrix A and the second one B. We use the US elections results of 2004 to predict the outcome of 2008 and so come until to predict 2016. In our calculations, we change our data from percentages to decimals to have a more properly matrix calculation. We use the double stochastic matrices, and matrix A indicates the party preference and voting time, and matrix B indicates the results obtained by each party.
So here's our matrix example. As my colleague said, we're going to make a matrix A and matrix B. Matrix A is composed by the percentage of voters from each party, corresponding that the first row and first column is the Democrats voting Democrats. The second row and first column is the Democrats voting Republicans, and the third row and first column is the Democrats voting independents. And our matrix B will be the percentage of the results from the previous election. In the first case, will be from elections from 2004. So our first case is 2008 elections. We made our matrices A and B from the results, as I said before, of 2004. And we just multiply our matrices and we get the results that predict the final result of the elections. But in this case, as we had to change a little bit our results, but they were looking really similar to the final results. Then our second case, 2012 elections, we made up as well our matrix A and our matrix B. In this case, from the data from 2008. And we multiply them, and we arrived to the conclusion that the results were almost the same with the real results that were finally in the elections. And finally, 2016 elections, the same. We made up our two matrices, matrix B with the data from 2012, and after multiplying them, we just got a little difference from some decimals, but were almost the same results. And then we decided to try to arrive to the matrix equilibrium. That's saying that getting the matrix that will predict our result in an infinite time. So we just form our matrix of x, y, and z and solve the system of equations. And finally, here we have a graph showing what were our results and the real results comparing 2008, 2012, and finally 2016.
So, the conclusions. The method is useful as long as it is used with the latest electoral data. Why? Because the greater the years that have passed, the more inaccurate results you will get. It is useful when the only determining factor is the popular vote. And as well, it is important to say that the more data you have, the better in order to arrive to this result. The Markov chains can also be used for other purposes. For example, they can be used to measure company loyalty. They can be used as well to measure the behavior of different social groups for different issues. And as well, they can be used in finance, for example, to predict the price of a stock in the next quarter.